Oh, guys, so this is a video on quantum numbers and nodes. So, let's start with quantum numbers. There are four quantum numbers basically: principal quantum number, azimuthal quantum number, magnetic quantum number, and lastly, spin quantum numbers. And then we're gonna talk about nodes. So, first of all, the principal quantum number, it is basically KLMN, which you know since your birth. So it was given by Niels Bohr. You know who that boring person is, Niels Bohr. And it represents main shell, size, energy level. These are very important things. Literally, these are the very important, and it is basically these are things which are going to be asked in nature ability questions. So applications of these equations of these are going to be asked, but the basics are really important for you to attend an exam. So let's stop all those things. In a main shell, size and energy level, whose value lies between 1 to infinity. Now the maximum number of orbitals in a shell is given by n is equals n square. N is nothing but the principal quantum number. Yeah, n square n. So the maximum number of orbitals is given by n square, maximum number of electrons is given by 2n square. For hydrogen and hydrogen-like species, one having one electron in their atom, the energy of the orbital depends on the value of n. My voice might be changing second to second, but it's because of my problem, not a problem. So second is azimuthal quantum number represented by L, and it represents SPDF. Over here it shows KLM, and wow, it shows SPDF. So it's basically like this. And yeah, it was given by Sommerfeld, and it is also called as subsidiary quantum number, or biangular momentum quantum number, or secondary quantum number. They may just not ask you about how many azimuthal quantum numbers are there. They might ask subsidiary quantum numbers, orbital quantum numbers, and secondary quantum numbers, and like, what? How is it possible? It's not in the syllabus, and how could they give all those things? To prevent all those things, just know they're also called as names. So it represents subshell. Here the quantum number represents main shell, it represents subshell, okay? And here it represents size, here it represents shape, it represents energy level, it represents orbital angular momentum. Just compare and you're gonna remember it. Yeah, so it's like that. And yeah, the magnitude of orbital angular momentum, or the azimuthal quantum number, is given by under L into L plus 1 h upon 2 pi. It determines the energy of the orbitals, okay? It determines energy of the orbitals in multi-electronic species, and the value lies between 1, 0, 1 to the till n minus 1. Basically, this thing over here, the star which you can see, is important thing. If the value of L is 0, then it is S. If it's 1, it's P. If it's 2, it's D, and so on. 3, P, and so on. As you can see here, N is 1, L is 0, subshell is 1s, and it is 2, 0, 1, 2s, 2p. It's like that. And then the maximum number of orbitals for a given value of the L. So they might give the value of L as x. Suppose x, then they might ask the maximum number of orbitals for that. It's 2L plus 1. Simple. Just put the L value in between the formula letters in the place of L. Ta-da! You'll be there with the right answer. And the maximum number of electrons. This is important. For orbitals, 2L plus 1. For electrons, it is 2 into 2L plus 1. This is where you're going to mess up with. So it's 2L plus 1 for orbitals and 2 into 2L plus 1 for electrons. The shapes of subshells, the shapes is for S it's spherical, spherical. It is dumbbell, it is double dumbbell. For D, it is complex, just like anything. So it's like that. Now we are done with this. Moving on to magnetic quantum numbers, it is written by ML, given by Linde. Who is that? It's Linde, not Sunday. It's Linde, and it represents the orientation of the orbital in 3D space. The value of the value of Linde, or the value of L, lies between minus L to plus L. So yeah, you just put the value of L over here. They'll give the value of L. Just put it, and you will get to know the magnetic quantum number. So for S the ML value is 0, which means it has one magnetic quantum numbers, because for S the value of L is 0, right? Now put the 0 in here, over here, they will get 1 obviously, so it has one magnetic quantum number. Talking about the D, so the value of L for D is S को होगा 0, L को P को होगा 1 and D को होगा 2. So just put 2 over here. 2 into 2, 4 plus 1, it's basically 5. You're getting 5. You can just see here, you're getting 5. So it's just so simple. You just need to remember a few things and you'll get that. Yeah, we're done with that. Next is spin quantum numbers. Sorry for the disturbing voice, because I laughed before making this video. I ate the dahi puri, I ate the pudding, that's Rupai wali. Yeah. No, it was not pudding, it was cupcake or whatever. It is Erlenbach. It was given by Erlenbach. Beck. It represents the spin of electron, the spin. And it is not derived from Schrödinger. It's very important, guys. The above three, that is N, L, and ML, are derived from Schrödinger wave equation, whereas this shit is not derived from Schrödinger wave equation. So basically, it has two innocent values. No, not innocent. It has two values, that is S is equals to plus or minus half. Total spin, you can get total spin when the value of n is given, plus or minus n by 2, just n is no, sorry, n is number of unpaired electrons. Please don't get it. I'm just gonna highlight it. Yeah, number of unpaired electrons, it's really important. And spin angular momentum is given by under root s into s plus 1 h upon 2 pi. Yeah, and the magnetic momentum, oh my god, the magnetic momentum mu is given by under root n into n plus 2 into n plus 1, n plus 2, under root n into n plus 2 Bohr magneton. Please don't confuse it with n as principal quantum number. It is the number of unpaired electrons, okay? Next, we are gonna, over here it is under root s into s plus 1, and as you can see here, we have similar kind of formula over here for a simple quantum number under root L, and it is for magnitude of orbital angular momentum. Oh shit, man, I showed you that. Thank you, Wala. Okay, nodes. The number of nodes. Nodes is basically the probability of electron in the 3D space. It is just the probability that you can find an electron is 0 over there. Okay, the probability of finding an electron in a 3D space is 0. You can't really find that. It's impossible to find you there. And not the code which says everything is possible. No. The nodes, these nodes prove it wrong. Because the probability of finding an electron at nodes is 0. You get that? It's 0. So there are two types of nodes. Oh my god, I'm so sorry. My voice, yeah, you might hear the voice of turning pages. Yeah, because I have the turning pages voice syndrome, because I'm a NEET aspirant. So, oh shit, I said you that too. Okay, next is radial or spherical nodes. There are two types of nodes. I talk about that: radial, spherical nodes, and angular or nodal plane. It is the probability of finding an electron which is 0 at certain distance from nucleus. Just remind this here, and at certain distance x. So it's not like that. And क्या हो रहा है भाई? Okay, चलो कुछ भी हो. And yeah, talking about the angular nodal plane, the probability of finding an electron is 0 at certain planar surface. You know, the planar surface, x, y, this. Oh shit. I'm actually a good artist, but not in the tab. Yeah, and the value, the angular node formula is L, and for radial node it is n minus L minus 1. N is quantum number, N is obviously is quantum number, N is principal quantum number, L is azimuthal quantum number, so 1 is a digital number, if you know, for your information. L is basically azimuthal quantum number. And if you want to calculate total number of nodes, then just put n minus 1. It's so simple, but you are gonna forget. Just write down on a sheet of paper and you get it there, and revise it until fit that in your mind. So that's it for the video and for the title given. Thank you so much, guys. Thank you. Yeah, I hope the video was informative enough for you to know about. Yeah, actually this is enough for if you're preparing for the NEET in JEE thing and all. Yeah, thank you.